Good day, viewers. Welcome to another lesson. My name is Khalid Diallo, and today we are going to look at properties of solid shapes. And under the properties of solid shapes, we will be looking at cubes and cuboids. As we all know, solid shapes are also referred to as three-dimensional shapes. We will be looking at two of them, as cubes and cuboids. We will be talking about their properties. What are the properties that you will see in a certain solid shape to know if that shape is a cube or a cuboid. Although we have more than two solid shapes, in our subsequent lessons we will be talking about them as well. But in today's lesson, we will want to talk about the properties of cubes and cuboids. Like in three-dimensional shapes, there are certain words that we use when talking about their properties. Those are the vocabulary words for three-dimensional solids. The first one that we are going to talk about is going to be the face. You have flat surface. Now in solid shapes, that is the three-dimensional shapes, we have some certain words that we use in talking about their properties, like the vocabulary words for the three-dimensional solids. The first one that we have, that we use to describe the properties of a solid shape, is the face. That is the number of faces that the solid shape has. Like for instance, if we have a solid shape like this, we will want to talk about the face. That is the flat surface that the shape is having. That is the solid shape. So like if you look at this area here, it will be referred to as a face. That is the area on the picture here. It will be referred to as the face. That is what we have here. Like for instance, here on this other one, as you can see, where we have the number 1, represents a face on the solid shape. Apart from the face, we will also talk about the edges. Now, what do we refer to as the edges? When you talk about edges on a solid shape, we refer to the line segment formed when two faces meet. When you have a solid shape and the shape has faces, wherever these two faces meet, they form what we call a line. They form what we call an edge. Still, like for instance, if you consider this solid shape, it is a cube. When you consider this shape, where we have the first face, that is face 1, and face 2, that is the second face, where they meet is what we call the edge. Regardless of what type of shape do you have, so long the shape has faces, wherever these two faces meet, like here, this is a face on the solid shape, and here this is another face on the solid shape. Where these two faces meet is what we refer to as the edge. So we will be using these vocabularies in our lesson. The third vocabulary that we will be using in our lesson is the vertex or vertices. The vertex or vertices. Now, what do we mean by the vertex or the vertices? It's a point where 3 or more faces or edges meet. It's a point where 3 or more faces or edges meet. We've talked about faces. We said the face is the flat surface on the solid shape. Then edges will be where 2 of the faces meet. That's what we will refer to as an edge. Then the third one now is where the point where 3 or more faces or edges meet. That is where we are going to call the vertices. Like for instance, if we consider this box here as a solid shape, we know that we can call this side a face, and we can also call this other side a face. Now, where these two faces meet is what we refer to as the edge. But in the vertices now, we are considering three or more faces. So if we have a face here, and we have this other one as a face, and this third one as a face, where they all meet, where all the three meet, is at the corner. Because the corner here, it meets with this side, this other face, and this other face. Now that particular corner is referred to as the vertices. Like for instance, if I have a plane shape like this, if I have a three-dimensional shape like that, you realize that here there's a face here. That is the face in front. That's a face of its own. Then we can have another face on top. That is, if we consider this box. This face here is what we have here, and the face on top is what we have there. And also, we can have another face here. Remember, they are all connecting each other in order to form a solid shape. So where these three faces meet is at this point. That's where they meet. They meet at this point. Now that point is referred to as the vertex or the vertices. So these are the three vocabularies that we will be using in talking about the properties of solid shapes. Again, we'll go over it one more time. We'll be talking about the faces, that is the flat surface on the shape will be referred to as the face. The flat surface on the solid shape will be referred to as the face. Also, where the two faces meet will be referred to as an edge or the edge. Where two or three faces meet will be referred to as the vertex. Now, it's not only about the faces meeting. It's not only about the faces meeting, and also when the edges meet, we can also call that a vertex. Like for instance, if we have this point, these two faces meet here to form an edge here, and these two faces equally meet here to form an edge here, and these other two faces also meet here to form an edge here. As you can see, three edges are meeting here. Now where these three edges meet is also referred to as a vertex. So I hope you understand the concept of faces, edges, and vertices. So we'll move to identifying other faces from other cubes. Like here also we said this one is a cube. So we want to verify how many faces does it have. How many faces does the cube have? In doing that, let's say this is the first face. So we are going to label that one as number 1. Then we look at any other side. Okay, here is another face. We verify and confirm that it's a face. Then we write number 2 there. We want to confirm how many faces does this cube have. Again, we've labeled 1 and 2. So we look at another place. Here we have another face here. So this face will be number 3. Remember, the goal is to find out how many faces does a cube have. We've labeled 3 places so far. And here also it's not labeled, so it's a face. We can have here number 4. So far we've confirmed 4 faces that the cube have. So we still go ahead and yes, there is another face here that is not labeled. So since we have 1, 2, 3, and 4, here is going to be face 5. Again, are we done? Let's move on and verify. Yes, we are left with 1 face here. So that is going to be number 6 in our list. So still, if we cross-check, you will come to realize that all the faces have a particular number. So we've exhausted all the faces of the cube. So in general, we can say that this cube has 6 faces, because we've verified that it has 6 faces, and the first one that we count equally has 6 faces. We'll move on to the third one and confirm still whether it has 6 faces, so that we can conclude that cubes have 6 faces. We claim that this is a cube, and we want to verify to see if it has 6 faces. So we are going to label each face so that we don't double count. The first face that we have here, let's say we are going to put a dot there. Okay, that is 1. Okay, another face, we are going to put 2 dots. That is the second face. We look at another face, here we have 3 dots to confirm. So we have 1, 2, 3. Then maybe we look at this other side, we have 4 dots. So it means we verify that this face is also counted as our number 4 in the list. Then we look at this other side, here we have 5 dots. 5 dots, that is going to be the 5th face. Then look at the last one where we can have the 6th face, and that's what we expect to have. That is this side. We expect to have the 6th face here, as cubes have 6 faces. So we confirm from all the 3 cubes that we have that they have 6 faces. So there we can conclude that cubes have 6 faces. So our answer is going to be, how many faces does a cube have? A cube have 6 equal faces. A cube has 6 equal faces. So we said in order for it to be qualified to be called a cube, all the faces have to be equal. So that is why I wrote 6 equal faces. Then we move on to the next one. How many edges does a cube have? We've talked about edges, and we said an edge or edges are formed when 2 faces meet. An edge or edges are formed when 2 faces meet. So we also want to find out how many edges does a cube have. Again, we have cubes here. We are going to count to verify how many edges do they have. Now remember, we said the edge or any given edge on this shape is where the 2 faces meet. So we are going to count one after the other. We have 3 cubes. Again, we are going to count all of them and verify how many edges are there. Now looking at the first one, where let's say 4 and 6 meet is an edge. We have 1. Where 3 and 6 meet is an edge, 2. Where 4 and 3 meet is an edge, that is going to give you 3. Where 3 and 2 meet, that is phase 3 and phase 2. Where they meet is also an edge, that is going to give us 4. Then we have where phase 4 and phase 5 meet is also an edge, that is going to give us the 5th edge. Then where 3 and 5 meet, phase 3 and phase 5, is also an edge. That is going to give us 6, if I'm correct in the counting. So where phase 5 and phase 1 meet is also an edge. That is going to give us 6 edges so far. And where phase 2 and phase 5 meet is also an edge. That is going to give us 7 edges. Where phase 1 and phase 2 meet is also an edge. That is going to give us 8 edges. Where phase 1 and phase 6 meet is also an edge. That is going to give us 9 edges. And where phase 1 and phase 4 meet is also an edge. That is going to give us 10 edges, if I'm correct in the counting. And where phase 2 and phase 6 meet is also an edge. That is going to give us 10 edges. If I'm correct in the counting, we have 10 edges. So can we count again and see if we are correct? Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So have we ticked all the edges? No. We have 11. Have we ticked all the edges? 11 and 12. It means in our previous counting we made a mistake, we've not counted it properly. So now we confirm that this cube has 12 edges. It has 12 edges. So we are going to use another cube and count how many edges does it have. We are going to do that for all the 3 cubes so that we can arrive at one conclusion as to how many edges does a cube have. Again, we have another cube. We've already confirmed how many faces it has. So we are going to count the number of edges that it has. Now where 1 and 2 meet is an edge, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have ticked all the edges, and in total we have 12 edges in the second cube. So we are going to do the same thing for the third cube to verify how many edges does it have. Again, remember it's a cube. We've confirmed that it has 6 faces. So we want to know how many edges does it have. Again, we are going to count. Wherever the 2 faces meet is what we refer to as an edge. So where these 2 faces meet is an edge. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's see if we ticked all the edges. Yes, we've ticked all the edges. So here also we can confirm from the third cube then that the cube have 12 edges. So we can conclude that cubes answer the question, how many cubes does how many edges rather does a cube have? A cube has 12 edges. A cube has 12 edges. Then finally, we move on to answering the third question. It reads, how many vertices does a cube have? How many vertices does a cube have? What did we say about vertices? Vertices is the point where three or more faces meet is referred to as a vertices, or where 3 or more edges meet is also referred to as a vertices or vertex. So we'll have to see wherever we have a corner, that's what we will refer to as a vertices. So again, the question is, how many vertices does a cube have? So again, we are going to verify by counting, and we will have to count for all the 3 cubes to confirm how many vertices does they have. So the first one that we are going to have here, we again take the corner. Here all the 3 meet. So we will call that 1. Then here all the 3 meet. We call that 2. And here we have 3. Then here we have 4. As you can see, 3 faces are meeting and 3 edges are meeting. So we call that a vertices. So far we've counted 4. Then we move on. Here they meet. We have that 5. Here 3 faces meet here. We call that 6. Here we have another one, which is going to be 7. And here we have another one, which is going to be 8. So we want to verify how many corners does it have. So far we've ticked all the corners. And the number that we count is what? Is 8. 8 edges. Sorry, 8 vertices, I meant to say. 8 vertices. So let's confirm from the other cubes to see if they also have 8 vertices. we have another cube here, the one that we use to count the number of faces that it has and the number of edges that it has. So we want to confirm how many vertices does it have. So here, there's one vertex here. We have 1, 2, 3, 4, 5. As you can see, I'm taking the point where the 3 faces meet or the 3 edges. We've counted 5 for now. Then we move on. Here we have another one. 6, 7, 8. So let's confirm if we have ticked all the corners, all the vertices. Yes, we've ticked all of them. And we counted 8 vertices from our second cube. So we move on to the third one to confirm how many vertices does it also have. Okay, like here, 3 faces meet here. So that is our first vertices. Then we have 3 faces meet here. The second, that's number 2. We have 3 here. Then 4, 5, 6, 7, 8. So let's confirm if we have ticked all the vertices. Yes, we have ticked all the vertices, and we can confirm that there are 8 vertices that the cube has. So what can we say about all the 3? We know that we counted all their vertices. That is the point where 3 or more faces meet or 3 or more edges meet. In this case, where 3 faces meet or 3 edges meet. And we realize that there are 8 vertices or vertex. So the answer to that question is going to be 8 vertices. Now we can conclude about cubes certain properties that they have. Whenever you have a cube, there are certain things that we need to know about the cube in order to qualify it to be called a cube. Whenever we are giving a solid shape and we realize that it has all these 3 properties, then we can conclude that it is a cube. The first thing is we are asked how many faces does a cube have? And we've counted all the faces in the 3 cubes that we have, and we've confirmed that they all have 6 equal faces. Remember, equal faces is very key in this. Especially when you are talking about cubes, equal faces is very key in it. All the faces have to be equal for it to be referred to as a cube. And the faces should be 6 in number. So a cube has 6 equal faces. Then again, we look at the second point, wherein we are asked how many edges does a cube have. We've counted all the edges in the cube, and we've find out that from all the 3, it has 12 edges. They all have 12 edges. So there also we can see that what another property of a cube is they have 12 edges. Then the third one, it says how many vertices does a cube have? Now we said a vertex is the point where 3 or more faces meet, or where 3 or more edges meet. That's the point we refer to as the vertices. Again, we use all the 3 cubes that we have and count all the vertices that they have, and we've come to a conclusion that each and every one of them has 8 vertices. So there we conclude that cubes have 8 vertices. So whenever we are asked to state, or whenever we come across a solid shape and we want to examine if that solid shape is a cube, these are the 3 properties that we need to look for. And for us to qualify that given shape to be a cube, it has to have all these properties. It needs to have 6 equal faces, 12 edges, and 8 vertices. We move on to the next one. All right, before moving on, here are some examples of a cube that you can find in the in your environment. We have dice. A die is an example of a cube because all the sides are equal. And if you have one at home, you can take it and count how many faces does it have. You can also count how many edges does it have, and also count how many vertices does it have. You realize that it is the same thing as that of a cube, because the solid shape is actually a cube. Also, you can have puzzles. Such puzzles are also found in our environment. You can also take them and count how many faces do they have. You can count how many edges do they have, and you can also count how many vertices do they have. At the end of the day, you'll come to realize that it has the same as that of a cube, because the puzzle that you are having there is also a cube. Okay, we now look at another shape, another solid shape, and in this case, the one that we are going to discuss is a cuboid. Now, what do we need to know about cuboids? How do we identify cuboids when you come across with them in our society? How, if you are given many shapes, that is many solid shapes, how do we pick out the cuboids from them? There are special properties that we are going to look for that is going to qualify them to be referred to as cuboids. So the answers to the three questions that we have here will provide us with the adequate information that we need in order to find out if a given solid shape is a cuboid or not. The first question says, how many faces does a cuboid have? How many faces does a cuboid have? The second one is asking, how many edges does a cuboid have? How many edges does a cuboid have? And the third one is asking for the vertices that the cuboid have. Just like what we did in the cubes, we are also going to do the same thing for the cuboids. We are going to verify the number of faces that they have, the number of edges that they have, and the number of vertices that they have. That's what we are going to look for to confirm whether that given solid shape is a cube or a cuboid. It needs to fulfill all these properties. Also, I'll give you a little bit difference between the cubes and the cuboid, although I will talk about it later. When we talked about cube, we said they have equal faces. But in cuboids, it's a different case. So when we are talking about cuboids, you realize that they may have 6 faces, but the size of the faces may differ. So we look at the first one. We look at the first one here. This is a cuboid. And how do we know that it's a cuboid? Is the fact that the faces are not equal. Also, it will need to fulfill the properties of a cuboid, which we are going to talk about in a while. Once we know the properties of a cuboid, then whenever we meet with such shapes, such solid shapes, we will be able to tell if they are cuboids or not. So the first question that we are going to answer here is the number of faces that a cuboid has. Like, how many faces does a cuboid have? How many faces does a cuboid have? Now, this one has been already labeled for us. So we are going to count the number of faces that it has. So here, this flat surface is going to give us 1 on our list. We have 1. Then we have 2 here. And then we have 3 faces. We have 4 faces, 5 faces, and 6 faces. So far, we've counted all the faces that this cube have, and we can confirm that it has 6 faces. Again, what can we talk about the faces? What can we say about the faces of a cuboid? If you look at it carefully, you realize that the faces are not equal. Face 1 and face 3 are equal. Face 2 and face 4 are equal. Face 5 and face 6 are equal. So not all the faces are equal in this case. So that is cuboid for us. Then we will confirm from the other cuboid that we have 3 of them. We'll see how many faces do they have, and also we'll talk about the size or the sizes of the faces. We'll look at number 1 on our list. This is a flat surface, and it is referred to as 1 face in this cuboid. Then we have another one here. This is going to be number 2, the second phase. Then you have number 3, third phase. Then number 4, the fourth phase. Then number 5, the fifth phase. And number 6, the sixth phase. So now we can confirm that there are 6 phases in this other cuboid as well. We've confirmed from the first one, and we have 6 phases. And we've talked about the size of the phases, and we realized that the phases differ in size. So the second one too, we'll talk about the same thing. We'll see how many phases are there. We said there are 6 phases. And what can we say about the phases? You will see that phase 1 is the same thing as, is the same, of the same size with phase 2, and also of the same size with phase 3, and also of the same size with phase 4. All these 4 phases are equal. Again, let's look at phase 5. Is it the same with phase 1? No, they are of different size. And phase 6 is also of the same size with phase 5. So here we can say phase 1, 2, 3, 4 are equal, and phase 5 and 6 are also equal. So it is going to be classified as a cuboid based on the properties that we observe from the cuboid. We look at the third one. Here we have a box. We can have this at home. We can have boxes at home, and then we'll be able to confirm if they can be called cubes or cuboids when they fit in either of these two properties. So again, we have a cuboid here. We confirm the number of faces that it has. Here is 1, 2, 3, 4. We have 4 faces there. Then here we have another face, that's 5. And there we have another face, which is going to give us 6. So again, we've confirmed that this shape has 6 faces. This shape has 6 faces. That is the solid shape. It has 6 faces. Now, what can we say about the faces now? Let's see if all the faces are equal. Are they all equal? The answer to that question is going to be no. Because we see that phase 4 is equal to phase 2. They are of the same size. Phase 1 is equal to phase 3. They are all of the same size. And phase 5 rather, is equal to phase 6. They are all of the same size. So you realize that not all the faces in this cube as well are equal. So we can confirm that cubes have 6 faces. What we cannot confirm is the faces are not equal. So all what we can say is cubes have, cuboids rather, they have 6 faces. So the answer to our question, how many faces does a cuboid have? We have 6 faces. They have 6 faces. Then from the faces, we talk about the edges. We talk about the edges. How many edges does a cuboid have? Just like the cubes, wherever 2 faces meet, they form an edge. Wherever 2 faces meet, they will form an edge. So like we did in counting the number of edges that a cube have, we'll do the same thing in counting the number of edges that a cuboid have. We're going to see where 2 faces meet, and we count that as 1 edge to verify for all the 3 cuboids to know how many edges do they have. We start with the first one. This one will be the first one, and we'll see where 2 edges meet, and we'll count that 2 faces meet rather. We'll count that as an edge. So here, this is going to be 1 edge. That is where phase 1 and 2 meet. It's going to be 1 edge. Where phase 1 and 4 meet, it's going to be another edge. So we have 2. Where phase 3 and 4 meet, we have another edge here. That is going to give us 3. Where 1, 2 and phase 3 meet is another edge, which is going to give us 4. So far we counted 4 edges. Again, where 4 and 6 meet is 1 edge, we have 5. Where 6 and 3 meet, phase 3 and 6, we have 6. Where phase 6 and 2 meet, we have 7. Where phase 6 and 1 meet, phase 1 meet, we have 8. We continue counting. Where phase 5 and phase 6 meet, we have 9. Where phase 5 and phase 2 meet, we have 10. Where phase 5 and phase 1 meet, we have 11. And where phase 1 and phase 5 and phase 4 meet, we have 12. Where phase 5, yeah, I think that's all. We've counted all the number of edges that the cuboid has. And we confirm that there are 12 edges. So we are not going to stop at this cube. We're also going to verify from the other cubes and count how many edges do they have. Again, we have this other one. We are going to count the number of edges that it has. Here we have 1, 2. Remember, we are considering where the two faces meet. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is that all? Yes, you will realize that we have ticked all the edges that are on this shape. We have ticked all the edges, and the total number that we have 12 edges. So we'll count for the third one as well and see how many edges does it have before we conclude our answer. Again, we said this one is a cuboid because it has 6 faces and none of the faces are equal. I meant to say not all the faces are equal. So we want to verify how many edges does it have. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and here we have 12. So again, we've confirmed all the edges, that is where the two faces meet, and we have 12 edges when we count it. So we can also conclude from the third cuboid that we have, it has 12 edges. So there we can conclude that cuboids have 12 edges. 12 edges. Then we move on to the next question, which reads, how many vertices does a cuboid have? How many vertices does a cuboid have? We said vertices are points where 3 or more faces or edges meet. Vertices are points where 3 or more faces or edges meet. Like for instance, here phase 1, phase 5, and phase 2 meet at a point here. That's the point we refer to as the vertices, where the 3 faces meet. Or if you look at this edge and this other edge with the edge down here, they all meet at this point. So that point we will refer to as a vertices. So the question is, how many vertices does a cuboid have? We have 3 cuboids as well. We are going to confirm how many vertices do they have. We'll count. We confirm from all 3 before we draw our conclusions. So we'll count the first one here. Here we have 1, 2, 3, 4, 5, 6, 7, and here we have another one, 8. So did we tick all? Yes, we ticked all. So we have 8 edges, 8 vertices, I meant to say, 8 vertices. Then we look at this other one. We want to confirm how many vertices does it have. That is where 3 or more faces meet or 3 or more edges meet. So here we have 1, 2, 3, 4, 5, 6, 7, 8. Also, we can confirm from the second cuboid that it has 8 vertices. Then we move on to the last one to confirm how many vertices does it have. Again, we have 1, 2, 3, 4, 5, 6, 7, and 8. So from the third cuboid also, we've counted 8 vertices. So there we can conclude that cuboids have 8 vertices. 8 vertices. So whenever we come across with a solid shape, once we can determine how many faces does it have, how many edges does it have, and how many vertex does it have, and it falls that it has 6 faces that are not of the same size and 12 edges with 8 vertices, there we can conclude that that particular solid shape is a cuboid. That particular solid shape is a cuboid. So I hope you will be able to identify cuboids whenever you come across with them. You'll be able to confirm the properties that they have to see or qualify them to be called cuboids or otherwise. So we move on. Okay, here we have some questions that we want to answer together. The first question is, what 3D shape is this object? That is, what 3-dimensional shape is this object? We've talked about cubes and cuboids, and those are the two that we are concentrating on in this lesson. We've talked about cubes and cuboids. So what shape is this one? The one that we have here. Where do we classify it? In which 3-dimensional shape? The first option says cylinder. The second option says a sphere. The third option says a cone. And the fourth option says a cube. So far we've not talked about cylinders, spheres, and cones. What we talked about is a cube. And looking at this shape here, you will see that this face in blue is the same with the face in yellow and of the same size with the face in red. I understand that. When we count, let's say it looks like this. So when we count, we realize that it has 6 faces. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 faces. So it has 6 faces. How many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and finally 12. So it has 12 edges. And the number of vertices that it has, we have 1, 2, 3, 4. We have 5, 6, 7, 8. It has 8 vertices. So therefore, this shape here is going to be classified as a cube. So the correct answer to this question is going to give us option D, as the shape is a cube. Then we move on. We have another one, and it says, what shape? This shape has 6 faces, true or false. This shape has 6 faces, true or false. Well, let's look at the shape and see if it has 6 faces. First of all, what does it look like? Do we call it a cube or a cuboid so that we can confirm the number of faces that it has? It says, the question says it has 6 faces. We want to verify before we conclude that the shape has 6 faces. Let's see. Well, the face is a cuboid and we have a cuboid. So let's confirm how many faces does it have before we conclude to the answer whether it is true or false. Well, here we have 1 and 2 3, 4, 5, and 6 faces. So a cuboid has 6 faces, and the shape that we are giving is a cuboid. So the statement is going to be true that this shape has 6 faces. So the answer to that question is going to be true, and that is going to be the first option, option A. Then we move on. How many faces does this shape have? How many faces does this shape have? Well, we have the shape on the board here. I think a replica of that shape is going to be this one. This is going to be a replica of it. So we can count, since we have the solid material here, we can count how many faces are there to be able to answer our question. So here we have 1, the first face 1, 2, 3, 4, 5, and 6. So how many faces are there? There are 6 faces. So the correct option here is going to be option B, as the shape has 6 faces. Then we move on. We have another one. It says, how many corners does this shape have? How many corners does this shape have? Remember, I said corners is the same thing as the vertices or the vertex. So it's asking about how many corners does it have. Again, this shape is a replica of it. It's all the same. So we can also count how many corners does the shape have to answer the question. How many corners? That is where 3 or more faces meet. In this case, where 3 faces meet or 3 edges meet is what we are going to refer to as the corner here. So we count how many corners do we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 corners. So just like here, we have 1, 2, 3, 4. Those are the corners on top. And down here also we have 4 corners. We have 1, 2, 3, and the third one is not visible, but it is there. Just like here, we have 1, 2, 3, 4, and this other side also we have 1, 2, 3, 4. So 4 and 4 will give us 8. So we know that there are 8 corners. The correct answer here is going to be option D, as there are 8 corners that the shape have. Then we move on. Okay, here we have a table. It says copy and complete the table below. We have the shape, the name, the number of faces, the number of curved faces, the number of edges, and the number of vertices. The first one that we have, when you look at it closely, we know that it's a cube. It's a cuboid rather. So the name there will be cuboid. So how many faces does a cuboid have? I think now we should all be able to answer that question. How many faces does a cuboid have? How many faces does a cuboid have? So let's count. We have 3 cuboids here. We can choose any one of them and count how many faces does it have. So let's take this one and count how many faces does it have. How many faces does it have? You have 1, 2, 3, 4, 5, and 6. So we know that it has 6 faces. We are still dealing with a cuboid. It says curved faces. Curved faces. Well, do we have a curved face here? Do we have a curved face here? The answer is no. All the faces on a cuboid are flat faces. We don't have any curved face, so the answer to that point is going to be 0. We don't have any curved face here. So a cuboid don't have curved faces. They have flat faces. Then you move on to the number of edges. How many edges do we have? How many edges does a cuboid have? Edges is where the 2 faces meet. So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many edges does it have? The cuboid has 12 edges. Then finally, the vertices. The vertices is where 3 or more faces meet. That is, if 3 faces meet, the point that at the point where they meet is referred to as the vertices. Or where the 3 edges meet, where they meet is called the vertices. So again, we want to confirm how many vertices does a cuboid have. Again, we are going to count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. It has 8 vertices or corners or vertex. Then we move on to the next one, which is a cube. We have cubes here, so that is going to help us confirm how many faces, how many edges, and how many vertices do they have, and how many curved faces do they have if they have any. Well, it's a cube, so the name there will be a cube. The name will be cube because the shape that we have here, the solid shape, is a cube. Okay, then number of faces. How many faces does it have? That was we discussed that in the lesson. The number of faces that a cube have. Okay, so let's just count from the one that we have here. We have 1, 2, 3, 4, 5, and 6. So how many faces do we have there? We have 6 faces. Again, the next one is saying curved faces. Curved faces. Okay, let's see. Do we have any curved face here? No, cubes don't have curved faces. So the number of curved faces there will give us 0. From there, we look at edges. Edges, we said, is where two faces meet. Wherever they meet, they form an edge. So how many edges do they have? Let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here we can confirm that the number of edges in the cube is 12. And finally, we look at the vertices. The vertices now is where 3 or more faces meet. In this case, where the 3 faces meet. So they meet at a point, and the point we call them the vertices. Or where 3 edges meet is the point we refer to as the vertices. So let's count how many edges do we have there. How many vertices rather. We have 1, 2, 3, 4, 5, 6, 7, 8. Again, 1, 2, 3, 4, 5, 6, 7, 8. It has 8 vertices. It has 8 vertices. That is copy and complete the table. We've completed the table. And another question says, what can you say about the two shapes? What can you say about the two shapes? Now, looking at the table carefully, what can we say about the two shapes? We can say that they have the same number of faces, they have the same number of edges, and they have the same number of vertices. Now, how do we know that they are given different names? This one is a cube and the other one is a cuboid. Now, how do you know their difference? Their difference lie on the faces. When you come to cubes, all the faces are equal. All the 6 faces are equal. That is for cubes. All the faces are equal. These are examples of cubes. And a die is also an example of a cube. All the faces are equal. That's where you have the difference. All the faces are equal. But when you come to cuboid, although they also have 6 faces, but the faces are not equal. Not all the faces are equal. In this case, you will see that face 1, 2, 3, and 4, they are all equal, and 5 and 6 are equal. But if you come to this other cuboid, you will see that face 1 and 3 are equal, face 5 and face 6 are equal, and face 4 and face 2 are also equal. So in cuboids, not all the faces are equal, but in cube, all the faces are equal. That is going to be what we can say about the two shapes. With that, we come to the end of the lesson. I'm going to leave you with some work. That is your homework, and you will have to see exercise 2.1 and 2.2 of the geometry worksheet. See exercise 2.1 and 2.2 of the geometry worksheet and answer the questions that are there. I thank you all for your attention.